this is what I meant to click on. So we are on model selection today, right here. But it is worth noting that we only have 5 lessons left, right? And that it's really not even 5 lessons, right? Today is model selection. And then next week, we have 2 lessons on checking model conditions and fitting nonlinear trends. And then that's it for new information, right? We have on lesson 38, we have a block 3 review. On lesson 39, we have GR3. And then on lesson 40, we have a final review and a work day to finish up our final problem set, as well as get ready for finals, which are the next week. So on the one hand, hopefully that is inspiring of like there's finally light at the end of the tunnel. We just have to decide now, is that light daylight or an oncoming train? But it also means that we should make the most of what we have. I'm going to try to give you guys as much time as I can in each one of these classes back to you in the form of doing work, working on lab, asking questions, because I think being this close to the end of the semester, we are going to get more out of the class by you guys being able to work and ask questions than me talking at this point. And frankly, I should probably talk less the entire semester, but it's hard with an online. It'll definitely be different in person next semester. And I would be lying if I said I was not super sad that I missed out on having all you guys in physical class and I have to do it online. I think you guys all have been kicking ass online, but it is going to be a much different experience, I think, being in the classroom with everyone next semester. Okay, so as we get ready for that, just a couple things to mark on there, like I said, is look at what we have left, but also look at Lab 6, Lab 10, and GR3, right? Is that Lab 6 is coming up on Monday and Tuesday next week. Lab 10 is coming up on lesson 38 there, and then GR3 on 39, and then the finals after that. Also, to answer a question that a couple of people asked in the last few sections, our finals have to be done a little bit different than we do our GRs. I know normally what I do is I give you a window of time and say, hey, the GR is online. You can do it whenever you want. But for the finals, you will have to take, our final will still be online, but you have to take it during the period that you're assigned. Because in the past, we've had a handful of situations where someone showed up like, a little bit late to a chemistry final, and they said, hey, where were you? And the person said, oh, I was taking my Math 356 final, and it just finished 10 minutes ago. To which they said, oh my gosh, Math 356, how did they shouldn't have been overlapping. We do all the stuff to make sure they don't overlap. So unfortunately, because a couple of people are having trouble scheduling that, we have to make sure it's only in the window of your final period. So there's no chance of you overlapping and you can't throw me under the bus. Because again, as Jenna pointed out, it's all about me. Now, the other part of that is that you are going to get assigned to a final period for this class. I don't care what period you take it, but the registrar and everyone else does. So if you say, hey, they assigned me to period, I don't know, 1, and I'd rather take this test in period 5 or vice versa, that's fine with me. I just don't have the authority to approve that. That has to go through the registrar. So if you want to change it, then early on, talk to the registrar and say, I would like to change my Math 356 from this period to this period. And if they say, what did your course director say? You can say, he said it was okay, but they have to be the one to bless it. If they want to talk to me, I can send them an email or you can tell them to call me, but it has to be coordinated and approved through them. Just because I'm okay with it doesn't actually mean anything. Yeah, what do you got, Ness? Nestor, what do you got?
I was under the impression this semester that just like last semester, we didn't have the power to change anything with the registrar in terms of finals.
So whether or not they approve it, I don't know. I know that some people have had them changed. It's just it depends on how strict the registrar is being. So it's very possible that the registrar will say, no, everything is tied up and we can't do it and I'm busy and don't ask me, and that may be the end of it. But they do have the authority to change it if scenarios have changed. So it is possible that if you're like, for some reason, let's say you get scheduled for the very last period of finals for my final, and you've got space in your first period and you rather get done early, there's nothing wrong, unless someone in your wing has told me or has told you, there's nothing wrong of writing a short, nice message or email to the registrar saying, hey, my Math 356 final is scheduled during this period. However, it is offered online, and my course director has given tentative permission for me to switch from 11 to 1 if you authorize the change. Is that possible? And in theory, it's no skin off their nose. It's not like they have to find more rooms or anything, but they may have been told on high, don't change anything. But it's never, it doesn't hurt to ask if you want to. And the nicer and more submissive you sound when you're asking, I find the more you're able to get yeses from the registrar. So you don't have to, but as far as I understand, you're still allowed to. It just needs to come from them, because they need to actually change you in the system, in their system. What I definitely don't want happen, that'll get me and you guys in trouble, is if someone just takes the other one and somehow the register finds out they didn't actually change it. So that's what we need to avoid. Make sense? Cool. All right. Let's move on to today. So we were on Monday. I did a quick review because I've been gone for a while and now I'm back. We just review of saying, hey, big picture, what we've been doing for this whole block is, linear regression, which means the top part there represents that there's this theoretical real relationship between some variables that we will never know, right? There's this equation that represents that there's a relationship between the real value of our response variable y and some predictor variables x, right? And that beta naught and beta 1, those are the parameters that represent the real relationship. And this random variable epsilon that says, hey, even if I knew all of that, there's still some noise in the data that is going to distribute, right? Even if I knew the exact relationship between people's heights and their weights, there would still be a random noise, because for a 70-inch person, yes, the relationship tells me what the exact average weight is of a 70-inch person. The truth of the matter is some 70-inch people are going to be below the average rate, and some 70-inch people are going to be above, and that's with that random error. But all of that is very theoretical. We don't know that, and that's the whole reason we have this class, is because we are going to attempt to estimate that magical equation on the bottom here by taking a sample and coming up with these sample statistics, beta naught hat and beta 1 hat, that estimate those real parameters. And because we're estimating the real parameters, even though we put in a real predictor variable x, what we get out is a estimate or a prediction of what we think y should be, right? And then that last part is, and then we can get better and better and better maybe by adding more and more variables, but it's the same general idea. So before we move on with today, does anyone have any questions about how the top half and the bottom half are related and how they are different? Awesome. All right. So let's look at a scenario. Let's say I am trying to predict fuel efficiency, right? So when you look at the top of my screen here, you can see that based on what I told R to do, R is saying, hey, okay, you wanted to predict what the miles per gallon of a car is, and you are going to do that using the variables, how many cylinders the car has, what its displacement is, what the horsepower is, what the weight of the car is, what the acceleration, what year it was made, and what its country of origin is. And before anyone asks me, I'm not even going to pretend that I know what half of these mean. I could guess, but I am not a car guy. I have an idea. I can tell you what year and origin is. Displacement, I think that has to do with something about pistons and chamber and where the gas goes in. I am not that car guy. I open it up and I can do a couple of basic things in there. But someday maybe I'll try to find a picture of the car I drove in college. but the car I drove in college would prove to you that I am not a car guy, because I bought my car. The car I drove in college cost me $650, and it was a Ford Falcon Econoline, which, if you don't know what that is, if you ever watch Scooby-Doo, it's kind of like the Mystery Machine. It's just a big box, but mine wasn't even colored cool like the Mystery Machine. It was just a ugly, like avocado green color. And it had a seat in the front and the back, and due to some amazing choice of design, the engine is between the driver and passenger seat. So when I sat in the driver's seat, I could open up the engine between me and the passenger. It had what's called 3-on-the-tree shifting. So the shifting was up here. It had power nothing. So I had to like turn the wheel 8 times just to make a left turn. And then the great part was, it had, when I bought it, there were no seats in the back. And so I did not have enough money to get seats added. So what I did, because I thought I was smart, was I went to Salvation Army and bought a queen size bed and a lot of pillows. And so the back of the van was just, oh, I'm sorry. And it was metal on the bottom. So that seemed like a bad idea. So I went and bought shag carpeting and glued that down to the back, and then put a giant bed and a bunch of pillows up there. And there was no dome lighting, so I ran Christmas lights all around it. I promised that the van did have windows, and it did not say free candy on the outside. But the point is that I drove that car and thought it was cool. So obviously I don't know anything about cars. So getting back to what we had here, we are trying to predict miles per gallon using all of these variables, right? And so today's lesson, if you read the guided lesson, is about building what we call a parsimonious model, which is just a big word to say the best model we can make up, right? Because we've gotten to this point where we can do multiple regression and we can add more variables. And R is great, because back in the day, every time we added a variable, I had to do a bunch of stuff by hand and it took long. But now I can give it like 100 or even 1,000 variables, and it still does it almost instantaneously. And so do we have enough variables? They just give you a giant data set, and part of your challenge is not just knowing how to build a model, but how to build a good model, right? And that's what a parsimonious model is saying, how do I decide which variables should be in the model? How do I take them in and out, right? And so this lesson talks about 2 main strategies for building a model. One is called forward selection, and one is called backwards elimination, right? So forward selection, which I'm not going to show here, is the idea of saying, I'm going to start with nothing, and then slowly, one variable at a time, I'm going to add a variable, see if the model gets better. If it does, keep it, and then add another variable, and keep doing that until I get the best model. Backwards elimination is basically the opposite of that. I throw in all my variables, I get one big model, and then I slowly, one at a time, look at the variables and I say, which variable looks like it is the least helpful? I take that out, see if I'm doing better, and if I am, I leave it out and then try to take another one out. If I'm not, I put it back in and try another one, right? And so that's kind of the overall difference between forward selection and backwards elimination. Now, once I am doing that, I have 2 approaches to decide which variables to take out. One is the adjusted R squared approach, right? Because we've talked about this, this number down at the bottom is a measure of how good my fit is. And so the R squared says, if I'm going to do backwards elimination, build my whole model, and then one by one, take every variable out and put it back in, back in, and see which one, how do I get the biggest adjusted R squared? And whatever the biggest adjusted R squared is, keep that, and then start the process over again until I can't make my adjusted R squared any bigger. The other way, which I was going to show here, is what's called a p-value approach, where I build my full model, and then I say, I'm going to look at the p-values for all of the coefficients for all of my variables, and say, which are the largest ones, and look at those to get rid of, right? Because hopefully you guys looked at it while I was gone, but here's the slides I would have shown you guys if I was here. But this is, So this is kind of the basic output of a regression model, right? And so we've been focusing on these numbers right here, right? And those numbers are, like I said over here, these are the estimates for the coefficients, right? So they are telling me what is the relationship between two things, right? Here I am trying to predict revenue with the budget, right? So this right here is an estimate of the coefficient for budget, right? All these other numbers over here are basically the numbers for hypothesis tests, right? And so for every row in there, R is doing this hypothesis test where it is saying, hey, for every one of those betas, we are going to do a hypothesis test where we assume that the beta is 0. And the alternative is that it's not 0, right? So when we say hey, I am assuming that beta 1 is 0, that is a way of saying my null hypothesis is that there is no relationship between revenue and budget, meaning the coefficient should be 0. That term should not be in there. And that is my null hypothesis. So when I get a very small p-value, because that's what that last column is, what that means is that I have very strong evidence that I should reject that null hypothesis, meaning that based on the analysis of this sample, there is very strong evidence that there is a relationship between budget and revenue, which is another way of saying that I should definitely include budget in my model because there is very strong proof that budget is related to revenue, that it has predictive value, right? So I can use that p-value as a way to decide which variables I might want to prune out of my model, right? Because I just threw everything in here. But when I look at the p-value for acceleration here, it is 0.78. That is very high for p-values, as you guys know, right? And so based on that very high value, what R is trying to tell me is, hey, you told me to build a model where acceleration is one of the predictor variables. So I did it because I'm R and I just do what I'm told. However, I do not have a lot of proof that we should reject the null hypothesis that acceleration is not important. And so it's basically saying, and I'm doing a lot of math hand waving here, it's basically saying there's about a 78% chance that acceleration has nothing to do with predicting miles per gallon. And so to me, that says I might not need acceleration in my model. A, by leaving it out, my model is going to be smaller, and so it's going to be easier to deal with. But B, all of the other coefficients are going to be more accurate if I take acceleration out, right? So I can go ahead and do that. And if I take acceleration out, meaning it's not in here anymore, as you see in there, I didn't ask it to include acceleration. So it's not showing up in this list here. And as a result, I don't know if you remember the adjusted R squared. My adjusted R squared actually went up a little bit. So this model is now, if it's not my parsimonious model, it is closer to a parsimonious model because it is more efficient. I have fewer variables. All the variables have pretty good, meaning small p-values, and my adjusted R squared actually went up. And so that was an example of something that I would definitely want to prune out of my model to make it more parsimonious. Before I go any further, any questions on how I made that decision and why this is a better or more parsimonious model than the other one? Now, when we use the p-value approach to remove variables, a lot of times we pick a level, kind of like we do in alpha, and say, I'm going to keep going until I have removed everything that has a p-value above that. Now, two things to remember about that. One, I still have to do it one at a time, right? Because every time I remove a variable, it will recalculate the model and all the p-values will change. So I can't just look at this this original model that had acceleration in there and say, I'm just going to find all the p-values there that are above a certain level and get rid of all those variables and redo the model. I still have to do it one at a time because when I remove acceleration, all of these p-values change. So it's possible that by removing acceleration, the other one that I was going to remove that had too high of a p-value, now the model does a better calculation. It says, oh, now that I don't have to think about acceleration, actually this one is much better. And so you do it one at a time. The other thing that I want to point out is, let's say I picked a alpha or a level of 0.05, right? So I said, I'm going to keep removing or pruning variables until all the p-values are below 0.05. Well, if I did that, I might look at this one right here and say, uh-oh, that one is above 0.05. I got to remove that one. I can't do that. Can anyone tell me why I can't do that?
Because it's an indicator variable and there are multiple other indicator variables you have to consider.
He's exactly right, because cylinder 6 or sil 6, that is not a real variable, right? It is a dummy variable. It's an indicator variable. When I look up here at all the things I told it to consider, sil 6 isn't up there. The only thing that's up there is sil, because that is a categorical variable telling me what kind of engine it is. Is it a 3-cylinder, 4-cylinder, 5-cylinder, 6-cylinder, or 8-cylinder, right? And as we've learned, the way R deals with categorical variables is it makes a indicator variable that's either 0 or 1 for each of the possible values, right? So cylinder 6 or sil 6, that is the dummy variable that is 1 if it's a 6-cylinder engine and 0 if it's not. And so I can't just say, oh, you know what, the other ones look good, but that one doesn't. I'm going to take out cylinder 6. I either have to take out cylinder altogether or not at all. If I take out cylinder altogether, then I would lose all of these. And looking at all of those numbers, it looks like when I look at the cylinder numbers that most of them actually have very small p-values. So the type of engine is important, which makes sense, right? If we're talking about miles per gallon, as I've already said, I don't know a lot about cars, but I know that the type of engine probably has an impact on the miles per gallon. So all that's really saying is that the 6 cylinders seem to not follow the same pattern, but everything else does. And so I got to keep that wholesale or not at all. And so in this case, I would have to make a judgment call and say, yeah, cylinder 6 is a little bit above 0.05, but it's not much. And all the other ones are really good. And so it's not worth losing cylinder because of cylinder 6's performance in there. To use an old term, I don't want to throw the baby out with the bathwater, right? So that's why I can't, I would leave this as is. If this was me, this would probably be my parsimonious model. All right, before we move on to the next idea of what might affect a parsimonious model, anyone have any questions on backward selection, forward selection, pruning variables, and what this p-value approach really means and why it kind of works and makes sense? All right, there's a lot of things that go into building a parsimonious model. Some of it is this, some of it is just common sense of saying, hey, what variables make sense, right? Like I might have had the variable color as another possible variable, but just from common sense, I'm going to say color has no effect on what my fuel efficiency is. So I'm not even going to put that in my model because that just is nonsense, right? And then we talked about what is contributing or not. The other thing that we might think about is this idea of collinearity, okay? So what I have here is several of the predictor variables, right? We are trying to predict, don't forget, we're taking all of our possible predictor variables and we are trying to predict miles per gallon. So here are 3 of the variables that I had: the weight, the acceleration, and horsepower. And I did a pairwise comparison to see how they are related to each other. So let me ask, Brian, you online this morning? No, Brian? I'll take Ryan too. I saw you jump at that before you heard me say the B.
Yeah.
All right, so let me ask you: Are there any variables here that look like they are related, that they are correlated to each other?
I would say for correlation, acceleration and weight look like they're, if I'm reading this, or sorry, horsepower and weight. I think that's
Okay, horsepower and weight. Yeah. So how would you describe that correlation?
I would say that it's linear, and it appears to have like a high strength correlation between the two. As one goes up, the other goes up. The others appear to lack linearity and show more of a weaker correlation.
Yeah, so I totally agree. I'd say there is a moderate to strong positive linear correlation between horsepower and weight. So now let me ask kind of a trick question. It's not really a trick question, but it's one I wouldn't be surprised if you didn't know exactly. Let me ask Kyler, you online?
Yes, sir.
So I agree with Ryan that horsepower and weight have a moderate to strong positive linear correlation. Do you think that is a good thing or a bad thing for the model we're trying to generate?
Well, I think it would decrease miles per gallon if that. Does that answer your question?
Kind of. So you're saying, you're saying it would, because what I'm trying to do is I'm trying to use these variables to predict miles per gallon. So with that being my goal, am I happy? Do you think that that strong correlation between weight and horsepower is a good thing, or do you think that's going to cause problems?
I think that would be good.
And that is a fair answer. And I'll be honest, I apologize. I was baiting you into trying to answer that. And so I assume that you knew what I was doing, but you realized, okay, Beatty wants his bottle. He wants to make a point. And so you gave me the answer you want, even though you didn't feel good about it. But he's exactly right. That's everything we've been doing this block is saying, let's try to get a regression. Is there a relation? Awesome. Now our equation is good, right? But all of that is when we are talking about, is there a relation between our predictor variables and our response variables? So I would love it if there was a relationship between weight and miles per gallon. And if there was a relationship between horsepower and miles per gallon, because that means weight and horsepower both are good at predicting miles per gallon, which is the thing I am trying to predict. But since this and this are both predictor variables, the fact that they are correlated to each other is actually not a good thing. It's what we call collinearity, right? Because what this means is if weight and horsepower have a collinear relationship, that means I could do a pretty good regression between the two of them, and I could come up with some equation that said something like weight equals some intercept plus some slope times horsepower, right? The fact that it has a strong relationship means that I could make some equation like this. Because I can make some equation like that, that means that when I am making my model where weight was, I could just write this equation, which is horsepower, which means I can write weight in terms of horsepower, which means I don't need weight, right? Because they are so strongly correlated. So when I have two predictor variables that are related to each other, they are collinear, and that means I only need one of them in the model. Not only do I only need one of them, I should only have one of them, because by having them together, it is going to complicate my model, because when R tries to make the coefficients for weight and horsepower, it is going to, the way it does that is it changes a bunch of things. It says, all right, when I change horsepower, here's how miles per gallon change. When I change weight, here's how miles per gallon change. But because weight and horsepower are connected like they are here, it's going to have a hard time deciding what is the impact that horsepower is having versus the impact that weight is having, because since weight and horsepower move at the same time, it's going to get bad coefficients because it's going, wait, was that horsepower that made that difference or weight that made that difference? And it's not going to be able to tell. So these are all issues that when we have collinear predictor variables, it is a problem, and we need to remove them until we don't have. So here I would say, hey, horsepower and weight look like they are collinear. So I'm going to get rid of horsepower. So I got rid of horsepower like that. Then I would say, okay, now I'm going to look at weight and acceleration. And when I look at those, I go, yeah, those don't look like, maybe a very weak relationship, but they don't look like they're collinear. So I'm going to go forward with my model of weight and acceleration. And now I've gotten rid of collinearity. But then when we get back into here, we then say, hey, yes, I got rid of that, but now when I look at acceleration has a crazy high p-value. So yes, it's not collinear, but it's also not helpful. So then I get rid of it because of that. So these are a couple of things I need to look at when I'm building a parsimonious model. Is there collinearity? If there is, try to eliminate it where I can. Once I've eliminated collinearity, then I'm looking at which variables are actually helpful and predictive in the model, right? Here, I was just showing the predictive variables. If I added miles per gallon to this chart, which is the thing I was trying to predict, I would hope to see an actual good relationship here. And that would be okay, because that would be a relationship between a predictor variable and the response variable. When I looked here, I would probably see no correlation, because that would represent actually acceleration is not collinear, but it's also not related to the thing I want to predict. So I should get rid of it because of that reason. Questions on collinearity and what we're talking about here is the concept, why it's bad, how to remove it, how it relates to trying to build a parsimonious model. Okay, so then, with the time that we have left, here's what I would like you guys to try to do. I'm going to actually, it's posted online, but for convenience, let's see if I can just share this with you guys. So I am going to just share this blockbuster.csv. So what the blockbuster.csv file is I went on to IMDb and I downloaded a bunch of information about a bunch of movies over the past couple of decades and put it all into this data file. So much like I said before, there is a lot of information in here. Some of it is useful, some of it isn't. It's on you to figure out. So what I'd like you to try to do is basically kind of play with this data, and I would like you to try to build a model to predict the revenue of a movie. So revenue should be your predictor variable, but to get to that point, you need to kind of go through these steps, right? First, you need to actually load this data set I gave you. Then I need you to look at it and try to decide which of the variables should be factors, right? Budget is obviously a numeric value, how much money the movie costs. But something like, I don't know, the month that the movie was released in, that is more of a categorical variable, because, you know, December is not 2 times June. That doesn't make sense. It's just, even though it's stored as a number, it's a factor. So look for those and change those to factors. Then I would say try making a subset of just your numeric variables and doing a pairwise comparison to see, are there any variables that are collinear, right? I will give you as a spoiler that I believe votes and popularity may be collinear, right? And use that to say, okay, I'm not going to, for collinear variables, I'm only going to include one. Then try to build a full model, meaning build a model that just includes all the terms that you think might have a chance of being important. And by saying a chance, what I mean is things like, for example, one of the variables is the tagline of the movie, right? Which is just not going to be, there's nothing you can do with that. And so I would leave that out. Now I say there's nothing you can do with it. If you really want to get into it, you might actually, if you made a new variable based off of tagline, maybe you find some useful information, right? Maybe you use grepl to say, hey, I want you to look at the tagline and tell me which taglines include the word revenge, which ones include the word love, and which ones include the word like funny, right? And say, hey, you know what? It turns out if I use that categorically, that movies that have the word revenge in it make $100,000 more than movies that have the word love in it. So that would be interesting, but you don't have to do that. Once you build that full model, then what I want you to do is see if you can try to build a more parsimonious model by looking at the p-values and adjusting and taking stuff out. And let me know what is the best adjusted R squared you can get. I'll tell you last section, I didn't try too hard, and I got a adjusted R squared value for predicting revenue, I think of about 0.55 or 0.56. I can't remember. So if you can do better, that is awesome. So start working on that right now. If you get stuck on any of these steps, importing it or building it or doing comparison, let me know as soon as you can, because I want to be able to help with that and make sure you can do code like this. But more importantly than doing the code, I want you to be able to understand it, right? And understand why you're doing the things you do, or what it looks like, because obviously I can't have you build something like this on the GR or the final, but I can give you some type of results, and you need to be able to interpret and say, what would be the next step you would do, or something like that. So think about that as you're doing that. And as soon as you're able to build a model or do anything, do any analysis, I would love it if you guys would be willing to take a screenshot of your model and drop it in the chat. I don't care if you're done yet, even if it's just your full model, to drop it in there so we can kind of start talking about and looking and saying, hey, here's what looks good about this. Here's what looks like, here's the next step I would do, and stuff like that. So please start doing that. And as soon as you get stuck, let me know, and I will endeavor to get you unstuck. All right, get to it. Okay. Are we getting anywhere on loading up the data? How are you guys doing? No one is seems like they're excited about sharing their models, which I totally understand. I haven't showed you mine yet, but I am curious as people bring in A, anyone have any trouble bringing the data set, and B, if you have, has anyone identified any variables that they think are collinear, or is there any variable that you have just looked at and said, hey, based on p-value, this has got to be in the model. This looks like it's got a high predictive value. I'm looking at mine right now, and it looks like I've got about at least three variables that I think are some of the strongest predictive value for this model that got to be in there. What do you got, Ryan?
I just made my pairs graph, and off of this, it's a little scrunched up because I've got it on two screens, but it looks like votes and revenue may have a pretty good comparison.
So you're looking at a pair. So that's cool. So you're looking at pairs where you've included revenue, which is your variable you want to predict. So you can definitely do that. But remember, just be careful that when you're looking at that, a relationship between revenue and any of the other variables is a good thing. A relationship between any variable and a variable that's not revenue, that represents collinearity, and that is a problem, right? So make sure you understand that difference. It sounds like you do, but I'm saying that for everyone else's benefit.
All right. Should I leave off revenue? You think that would be best?
Revenue is on screen what I have. Revenue is what I was asking you to predict. So revenue would be your response or your y variable. So you are including that as your thing to the left of the tilde, the squiggly line, if you want. And then you're saying, which variables am I going to use to try to predict that? So what you're looking for are variables that do show a relationship with revenue. But then when I look at that pairs, any variables that have a relationship with anything else besides revenue, I probably only need one of those variables at most, because those represent two predictor variables that are collinear. A relationship between a predictor variable and the thing I am trying to predict, revenue, is a good thing. A relationship between any two variables that I was going to use to predict revenue is a bad thing, because that's collinearity, and that means I probably only need one of them.
Okay. Okay. And then the second best one that I'm looking at is rating revenue, in my opinion, based off of these graphs.
Yeah, rating looks pretty good to me. The other big one I had was budget. Budget looked like because, and I agree, when you look at the pairs, budget looks like a little bit of a maybe messy cloud, but it does have a relationship. And then when you run the model with budget in there, budget has a very small p-value, which means there is a very small probability that budget is not important, right? And so for me, it looks like, which makes sense, right? The revenue of a movie is probably going to be directly related to the budget. You are not going to make, you're not going to make Avengers Endgame money off of a $10,000 movie. Maybe 1 in a million people do, probably even less than that. But more likely, the more money you spend, the more money you make. That's just how America works. Whereas I think, what was one of the ones I found that did not look important at all? To me, it looked like, what do I got here? Where's my first model? I actually had, to me, it looked like languages, which is the number of languages that the movie was released in. That one did not have a great deal. Its p-value was 0.36 for the model I was making. You might have got a different one if you included different variables, but that means there's about a 36% probability that it's not important. And so it looks to me like maybe the number of languages is not that important these days. All right. Well, we have a little under 2 minutes left, and I'm being told by my microphone that my battery is low. I'm going to die any second. So I am going to let you guys go and continue work on this, but I highly encourage you to continue work on this. And if you find something that you think is interesting, shoot me a picture so we can look at it. Otherwise, we will start talking about it first thing on our next class and see what you guys got on it. Because, like I said, this is a thing that I want you to be able to do, but more importantly, I want you to understand. So even if you don't give me anything, work on it and tell me what were the things about this that didn't make sense to you, or if I showed you someone else's results that you would not understand. So work on that. Be ready for that quiz and look for that last lab. And if I do not see you before then, I will see you bright and early on Monday morning. By bright and early, I of course mean. Have a great week and weekend, and I will see y'all on Monday.
Thank you, sir.
Of course.